In this next section, we're going to be moving on into some more particulars that are considered when doing statistical studies. Here, starting with different types of data and their levels of measurement. Data come in two basic types. Things like eye colors, like blue, brown, hazel, or ice cream flavors like vanilla, chocolate, etc. These are more like names or categories that data could fall into. Or we could have more numerical types of data like things like income of college graduates, numbers of students in a class, etc. So these are all examples of different types of data, but two primary categories that we see, one which is largely non-numerical and one which largely involves more numerical measurements. And so we'll break down these two data types into what we call qualitative and quantitative. Qualitative, or sometimes called categorical, data consists of values that can be placed into non-numerical categories. Quantitative data consists of values representing counts or measurements. So for an example here to highlight different qualitative versus quantitative data, it says classify each of the following sets of data as qualitative or quantitative. Starting with A, says brand names of shoes in a consumer survey. In that case, we're not dealing with numerical measurements when we talk about brand names of shoes. Those are more like names or categories. So we call that qualitative data. On part B, it says scores on a multiple choice exam. Well, this is more like a measurement of how many questions were right versus not right. So it's a counting measurement, the number of correct answers, and so we call it a quantity that measures, and so it's quantitative. On part C, however, a letter grade is not necessarily a measurement, so to speak, as a number. So it's more of a category, A, B, C, D, so forth. And so that'll be called qualitative rather than quantitative, because it's not, again, a number, it's just a letter grade. The last one says numbers on uniforms that identify players on a basketball team. Now this is a number, but it's not a measuring number. It's just a number that's used as a label to identify the player. So rather than thinking of it as something that counts or measures something, a number on a uniform does not count or measure, and so it'll be qualitative instead of quantitative. So those are some examples of quantitative versus qualitative. The primary characteristic of qualitative is that it's a number, but it's not just any number, it's a number which measures things. Whereas qualitative are names, categories, or labels that are being used, and they're not measuring anything. So within the quantitative data category, we can further categorize it into two subcategories: continuous versus discrete. Continuous data can take on any value within a given interval, whereas discrete can only take particular distinct values and not any values in between. So here are some examples. For each data set, what we're going to do is indicate whether the data is discrete or continuous. The first one says measurements of the time it takes to walk a mile. Well, if we talk about measurements of time, we can talk about fractions of a second. Any smaller increment of time can be measured with. On the other hand, when we talk about calendar years, such as 2017, 2018, 2019, we usually don't count with in-betweens, in between the years. It's just 1 year and then the next year. So we call that discrete. And one way of viewing it is there's no fractional in between years, like 2017.5 or something like that. So whenever they're listed out in distinct values with no in-betweens, that's what we call discrete. On part C, number of dairy cows in different farms. So would you think that would be continuous or discrete? Well, we wouldn't really talk about fractions of a cow. So we only have like 1, 2, 3, 4 distinct values listed. So that would be called discrete. They're all whole numbers. Now in the last one, though, it says the amount of milk produced by dairy cows on a farm. Now this one can take values in between. Like we could say 1.5 quarts or 1.45 quarts. So any fraction value, a decimal value could be taken. So that would make it continuous versus discrete. Now we can further categorize the levels of measurement by starting with something called the nominal level of measurement. And the nominal level of measurement consists of names, labels, or categories only. The data, when we talk about nominal level of measurement, is all qualitative. It's not a measurement in terms of a number and cannot be ranked or ordered. So nominal data is qualitative, but it doesn't have any natural ordering going on with it. So the word nominal here is referring to the names that are used for the categories. So for an example of this would be eye colors. Eye colors like blue, hazel, brown, things like that cannot be, there's no ranking or ordering to them, but they are the names that are being used to describe them. On the other hand, some types of qualitative data do have orderings to them, and we get what's called the ordinal level of measurement. And so again, this refers to qualitative data that can be arranged in some order, such as low to high. And so it generally does not make sense to do computations with data at the ordinal level of measurement. And again, that's because it's not really a numerical measurement. It's still a qualitative rather than quantitative measurement. So for example, when star ratings are given to a movie, those can be ordered, but the meaning of the difference between, let's say, 2 or 3 stars is not very clear. But since it's really not a, quote, measurement in the same way that a quantitative measurement would be, we're not really thinking about the numerical difference between them, rather just the simple ordering between them. Now, when we get back to quantitative types of data, there are 2 levels of measurement for those, so-called interval level of measurement. It applies to quantitative data in which the intervals are meaningful, but ratios are not. And so the key defining feature when we talk about interval level of measurement is that data has an arbitrary 0 point. So in other words, 0 is chosen at a point that doesn't necessarily have to mean that there's nothing present. So for instance, we say that things measured like in degrees Fahrenheit is interval level of measurement. 20 degrees Fahrenheit is not twice as hot as 10 degrees Fahrenheit. And this is all stemming from the fact that 0 degrees is chosen arbitrarily rather than to mean that there's 0 heat measurable. So one of the weird characteristics of interval level of measurement is we can't compare by ratio, one twice or big as the other like we see here. We can consider, one bigger than the other, but the ratios between them is not really definable. So that's what this says here. We know, however, that 20 degrees Fahrenheit is bigger than 10 degrees Fahrenheit, and this difference is meaningful. It's just that the ratio is not necessarily as meaningful. Now, ratio level of measurement applies also to quantitative data where both intervals and ratios are meaningful. So data at the ratio level has a true 0 point. 0 does mean that nothing physically is being measured. So for example, 10 kilometers is really twice as big as 5 kilometers because it measures at the ratio level, and 0 kilometers means literally nothing, no kilometers measured. And so here's a picture of the different levels of measure for each type of data. For the qualitative data type, it can be broken down into nominal or ordinal. For quantitative data, it can be either discrete or continuous. And within each of those, we could classify it as interval or ratio. So this is a good thing to come back to as you're working through some examples later on in the homework, to remind yourself which ones go with which as you get used to these different terminology that's being used here. So we're going to go through some examples to help identify the type of measurement, the level of measurement, being nominal, ordinal, interval, or ratio, for each of these different types of data. So the first one says numbers on uniforms identify the players on a soccer team. So we had seen this one a little bit earlier in this section where we talked about numbers on a jersey were not quantitative, rather they were qualitative because they weren't really a measurement. So it's qualitative, and in this case it would be nominal because there's no real ordering to jersey numbers. Though numbers do have a natural order like 1, 2, 3, 4, 5 that we usually put them in, they don't really rank person by uniform number. So for a number on the uniform, order doesn't actually have any meaning. So we call it nominal for that reason. It's really just a label or a name that's being used for each player rather than a way of ordering them. Part B, it says student rankings of cafeteria food as excellent, good, fair, or poor. Well, this one will be qualitative because it's not a quantity. So it's not quantitative, it's qualitative. And because we can actually rank them, however, there is a ranking from excellent to poor, we say it's qualitative and ordinal. So they are categories, but they can be ordered in this case. For the next one, calendar years of historical events such as 1776, 1945, or 2001. Well, this one goes now to quantitative because it is measuring the number of years. When we talk about quantitative, it could be either interval or ratio. In this case, it'll be interval because year 0 is not the actual beginning of time. So it's quantitative, discrete, and interval level of measure. And that's, again, 0 is arbitrary here for year 0 rather than the beginning of time. It's just chosen at an arbitrary point. So that's what makes it into the interval level of measure. The next one down, temperatures on the Celsius scale. For the same reason, this one's going to be quantitative and interval. It's interval because 0 degrees Celsius does not indicate the absence of heat. 0 degrees Celsius was chosen arbitrarily as the freezing point of water. So that's the only reason why we call it 0 degrees. So it's given by the interval level of measure. Notice we also say it's continuous as well, versus the discrete that we had on the number of years. And then the last one, runners' times in the Boston Marathon. Now this one is quantitative, continuous, and it will be ratio because we have a true 0 point when talking about the number of hours or minutes or seconds it took to run the marathon. 0 hours means no time has passed. So that's the key factor that makes it into a ratio level of measure.